increase the size a little bit here. We're going to download the project into this directory. I'm going to make a new temp, and I'll run the download command. Oh. Okay, it's now going to fetch the project, and we'll have it locally here. I can now cd into it, and this is our project. From here, the next step will be to run the notebook. If you're familiar with if you've used a notebook before, you can choose whether to do any kind of project run Jupyter Notebook, which is the classic interface, but you can also do Jupyter Lab instead, which is what I'll be using to demo. So this is now going to install the project. So it's going to go fetch the, I missed a step. I did not export this. Absolutely. Okay. So far we've kind of installed, hopefully you've installed Miniconda or Conda. You've fetched the Anaconda project. If you're on an M1 Mac, you've set this environment variable, which unfortunately you need for now. And now we're going to do Anaconda project run Jupyter Lab or Jupyter Notebook, depending on which notebook interface you prefer. All right, that's now fetching the packages. Might take a little minute. So if you want to follow along and you're not set up yet, you can go to holoviz.org/installation if you're just trickling in. So we're now solving the environment, it's installing it. If you've got everything set up, you want to make sure it's working. So there's going to be a notebook in the tutorial folder. So examples tutorial. If you go to setup, it would be good if you ran through that notebook, which basically just checks that everything's installed correctly. Okay. So after it's absolutely. It's also there at holoviz.org. Yeah. Okay. So yeah, Anaconda project run Jupyter Notebook or Jupyter Lab should be everything you need, and that should launch a Jupyter server. And basically, this is what you should be seeing now. And again, once you've done that, go visit the examples tutorial, open the setup notebook, and run through it. And it looks like it's pretty good. I see no reds. I don't see all the greens yet, but. All right, so you're going to have a little bit of time to run through things. You're going to have a little bit of time to run through things while I kind of give an broad overview of what we'll be covering and what these tools are. So don't panic if you're not ready yet.
So one more minute. Page here all this NGO. Back
No, I don't recognize anyone else either. It's good to have new people. Yeah. What's the atrocity?
Uh-oh.
what happened?
Anaconda project has a step that's conda where conda prints out what it would take to activate that environment.
Oh, okay.
You don't have to do that. It would work, but you don't need it.
You can do the whole path. All right, I think we're almost there now.
Yeah, ready to go. AV, are we okay? We okay? Okay. All right, so I introduce.
Let's let people settle, I guess. Yeah.
Okay.
I think we're good, yeah. All right, so one last time, if you're not set up yet, go to holoviz.org/installation, follow the tutorial installation instructions. You're going to have a little bit of time while I go through a quick overview. Yeah.
All right. Welcome to the HoloViz tutorial at SciPy 2022. It's the first time I have stood up without a mask to give a speech to a bunch of people wearing masks. So very hard to judge how I'm being received. So be elaborate with like, no, that means stop. Or, what? That means what? That sort of thing.
Yep.
So I'm Jim Bednar. I am the Director of Custom Services at Anaconda. But that's the last I will mention Anaconda because that's my employer. This is the HoloViz tutorial. HoloViz is an independent open source project. I work on it, as do 4 or 5 of the people in this room. Philipp Rudiger is the driving force behind most of HoloViz. Most of the lines of code that are in there are his, and most of the architectural decisions are his. And I kind of coordinate things. So he's the real person who makes things happen. And he'll be giving the tutorial until his voice gives out, and then if that lasts the whole time, fine. If not, I'll take over. So for those of you following at home, the way to follow along with this tutorial is to go to holoviz.org, HOLOVIZ.org, and follow the tutorial instructions under the installation tab. So everyone here should have already done that. If you haven't done that, put a little red Post-it note, and one of the people here will help you. The people to help you are Sophia over here, Ian over here, Maxime over there, me, Jim, and Philip if he's not talking. All right, so I'll hand it over to Philip.
Well, thanks so much. Isn't it exciting to be back at SciPy? It's been a long few years. I'm very happy to be back. And welcome to the HoloViz tutorial. So if you are not familiar with HoloViz, you might ask, what is it? So about 7 years ago, we joined Anaconda, and yes, that's also the last time I'll mention Anaconda, and started building various tools for doing interactive exploration of data in notebooks in particular, although all the tools here work just as well in a notebook, or if you're more familiar with kind of working in IDEs. And so we build tools for quickly exploring data, visualizing data, and then publishing the data and sharing the results with other people. And so all the tools that we build together kind of work together to allow you to have this workflow starting with some data. You explore it in a notebook or in your IDE. You then iterate and test some hypotheses. You then generate some figures, and now you're at a point where you want to share that. And so that's where some of our dashboarding / app development libraries come in. And really what we'll be focusing on is this exploratory step, and then moving on to this sharing step. And so HoloViz are a set of tools that help you do this, take you through the entire process. So holos means the whole. And so it's meant to give you this entire process from exploratory analysis to sharing your analyses. All right, so you might ask, well, does Python not already have enough packages to do this? And yeah, in fact, it's so many libraries that it doesn't even fit on the screen. So yeah, the Python visualization landscape is huge, right? You've got various libraries, particularly Matplotlib came very early. It's a great library to kind of generate static figures. And then there's various JavaScript-based tools to kind of do interactive plotting. And it's just a huge variety of tools. And we were like, well, let's give people the power to kind of, yes, do static figures, but also let's give them the power to do interactive plotting and so on, really dig deep into your data, do things you can't do with static tools, and then also work with very large data. And so we kind of built an ecosystem around this that will let you explore data easily. Why are there so many tools in the Python ecosystem? Well, again, it comes down to different requirements, right? You've got requirements where you want to simply build a quick plot. You've got very, very customized figures that you want to stick in your publication. But then you also have this process of kind of interacting in Jupyter, and there's various Jupyter-based tools. And then you kind of move on to tools for kind of building applications on a server that you want to deploy. And all of these conflict, right? There's always, like, a tool is best for a particular job, and that's really not what we wanted to do. We wanted to kind of take you give you the power to do all the things that you might want to do. So yeah, that's how HoloViz helps. We have tools that work very well in web browsers so that they can easily be shared. And so you can have remote data, you can have remote compute and execution. And most of our tools obviously focus on Python. That's why here at SciPy. But we also don't want you to have to write kind of JavaScript or CSS, although if you really want to customize things, you can do so. And you can also use these tools whether you have very small data sets that you can easily display in a single browser, or we have tools that allow you to scale out. And we'll kind of give you an overview of what all these different tools are, so it's a little bit abstract right now. And what we really want to focus on, that this interactivity works the same whether you're in a Jupyter notebook environment, or you want to deploy it, or you have a workflow that's not Jupyter-based. Although everything here obviously is going to be based on notebooks. And one of our real mantras is that we want high-level interfaces that give you the power to do things quickly, give you the power to kind of explore your data very quickly, but that they're not dead ends. At any point, you can kind of drop into a lower-level API, a lower-level interface to really customize your plots further, could build, customize your applications further. And so lastly, we kind of try to focus on APIs that you already know, right? There's enough libraries out there, so we don't want to come up with too many new APIs that you're not familiar with. And so that's really the focus of this tutorial. We're going to be focusing, that's a lot of libraries. We're going to be focusing some on APIs you hopefully are already somewhat familiar with. Yeah. So finally, I'll give you a quick overview of the different libraries that are encompassed by the HoloViz name. So the first one is Panel. We're going to get to that towards the end of this tutorial. Panel is a library that allows you to quickly prototype applications in your notebook and then deploy it. And so we focused on kind of giving you the power to use all the tools that you already know. If you're a Matplotlib user, you can use Matplotlib to generate your figures. If you already know, if you use Plotly or Bokeh, you can use those, right? And similarly, there's a whole page of various components that you can use with Panel. So really, the focus there was A, take you from notebook to deployed app very quickly, and B, give you the power to kind of leverage the tools that you already know. Similarly, hvPlot is a higher level interface on top of some other libraries we wrote, in particular HoloViz and GeoViews, and in fact Datashader, that lets you quickly generate plots in a single line. So if you're already familiar with pandas.plot, hvPlot is basically that, except it gives you not just static Matplotlib plots, but Bokeh plots that are interactive, that let you kind of explore things with widgets, that let you drill down into your data, into your very large data sets using the Datashader library. So Datashader is a library to quickly rasterize really, really large data sets. If it's a million points, a billion points, trillion points, you might have to scaling out. start scaling out to a cluster. But that's what that gives you. And then there's a few libraries that are kind of in the background. Well, Lumen in particular is a library that we're still developing. It's a low-code solution on top of Panel that lets you build dashboards with a YAML file. We won't cover that today. But what you might see a little bit today is Param. Param is basically the lower-level API that everything else is built on. It gives you, basically, if you're familiar with Python data classes, it's very similar to that, but actually precedes them by about 12 years, something like that. And that's what kind of allows you to link widgets to your plots and kind of give you the interactivity. And finally, there is ColorSet, which is just a set of perceptually accurate color maps, whether continuous or categorical, that you can use to kind of accurately plot your data. So that's a lot of tools, but we're really going to be focusing only on Panel and hvPlot here, and dig a little bit here or there into some of these lower level libraries that kind of make up this entire ecosystem. All right, so yeah, for us, the ecosystem becomes a little bit smaller. These are the tools that kind of we leverage as part of this ecosystem. You can see here, basically, a lot of these you can just drop your plots into Panel, but then also HoloViz and GeoViews and hvPlot kind of allow you to generate plots with Matplotlib, allow you to generate plots with Plotly and Bokeh. Yeah, I'll skip to that. So yeah, in this particular tutorial, we're going to be working with earthquake data, a fairly large data set. It might not be relevant to all your use cases, but it's a great data set to kind of work with for several reasons. It's pretty large, so we can kind of show you some of the support for large data we have. It has many different data types. So it has date times, it has place names, it has magnitudes, and so we can kind of really see how we're going to get a feel for the data of these different data types using these tools. And finally, yeah, there's two core APIs we're going to be kind of looking at in particular. There's the hvPlot.plot API, or in fact, .hvPlot is what we're going to be calling mostly. So if you've ever used Pandas or maybe Xarray, you know that they basically give you an ability to quickly generate a plot in a single line from your data frame, from your data set, Xarray data set. And so hvPlot, again, just lets you do that in an interactive way so that you get Bokeh plots, Plotly plots, Matplotlib plots, you get widgets, and we'll see that. And then secondly, we'll be looking at the .interactive API. So .interactive, one of the core superpowers really of Pandas and Xarray is that it lets you build these pipelines, data processing pipelines, right? You chain a bunch of methods together, you do, I don't know, you resample your time series, and then you do an aggregate, or, well, I don't know if that makes sense, but you get the idea. You can chain various operations, and .interactive gives you the superpower that at any point in that data pipeline, you can insert a widget instead of a regular argument, which really, if you think about it, that really gives you the ability to kind of, instead of typing 10 times, like you change some argument 10 times and re-execute the cell, you can now generate a little app to kind of scroll through different resampling intervals or whatever else you want. And so .interactive gives you the superpower of using APIs that you already know, but making them interactive. Right? And the final section in this tutorial will take you through using Panel. And so Panel, in the process of this tutorial, we'll be building various visualizations, tables, and so on. And now we come to a point where kind of, yeah, this analysis is interesting. I want to share this with my colleague. I want to send it to my boss because he doesn't like looking at code. And so that will let you kind of build you a little application that looks pretty nice to share in your organization. All right, so that's the kind of broad little overview, what you'll be learning today. So let's jump straight in. I think mostly everyone looks to be set up, so we can jump in from here. Let me just move over to the tutorial. All right, so as I said before, you have the choice of using either Classic Notebook or Jupyter Lab. I'll be using Jupyter Lab just because it lets me navigate more easily between these different notebooks and so on. But again, if you actually like Jupyter Lab, you can do Anaconda project run Jupyter Lab instead of Jupyter Notebook. So we're going to jump straight into the first section of this tutorial. So again, yeah, we're going to jump into the, if you go to example tutorial number 2, plotting, that's where we're starting. Okay, so this will be an introduction to hvPlot in particular. As I mentioned already, many libraries actually have a plotting API like .plot on Pandas. So in particular, obviously Pandas does. Xarray, if you're not familiar with Xarray, Xarray is basically a library for working with raster datasets. It's basically the Pandas version. It's a Pandas for gridded data, so images, stacks of images, and so on. So it's a great library. I don't know if it applies to your particular domain, but if you do, I would check it out. And hvPlot also lets you work with other datasets, so Dask, NetworkX, and a few others. But we'll be focusing primarily on data frames. So, as you usually do, you start with some data. In this particular case, we are starting with this earthquakes data set. If your machine is a little bit RAM limited, I would recommend kind of taking a subset, maybe 1 million rows instead of, let me remind myself, I think it's 21 million, is that right? No, I think it's 2 million. Okay, well, 2.1 million. Okay, that's not too bad. Hopefully that fits into your memory, but if you find your kernel crashing for whatever reason, I would recommend just taking a subset and letting that working with it. Yeah, absolutely. So the easiest way to do that is to just basically use the ilog method of pandas, and I guess that's, no, that's too many. Wait, what? Oh. That is very surprising. Okay, well, the easiest way then is using sample, precisely. So, yeah. Oh. Yes. Yes. Oh. Am I? Okay, I'll just write it out, because apparently I can't do exponents. Okay, so this will still give you, oh, right, I was just confused by the shape here. So yeah, if you want to do that, you can subsample with the sample method and give it n and then 1 million. Okay, so we're in fact actually going to work with a smaller data set because most plotting libraries are actually not too happy if you just, particularly interactive plotting libraries, are not too happy if you're dumping 2 million data points into your browser starts complaining a little bit and things slow down or crash entirely. So we're going to start with a very small fraction, just 1% of this data set, which is still 21,000 data points. And if you've ever used the .plot interface, you would have seen something like this, right? You can just use the .plot accessor on this data frame, you call scatter, you tell it, I want to plot longitude against latitude, and you get a little map. That's pretty nice. If you've in your environment, you should also be able to kind of switch between different Matplotlib backends. So for example, this is a nice, neat little trick. So you can actually get interactive plots with Matplotlib just by changing Matplotlib inline to Matplotlib widget. And so now we have kind of a somewhat interactive plot here. We can drag around. You can see it's not super smooth, right? When I drag around, it's not perfectly smooth, but I can resize. I can do a few things. So that's pretty nice. But really, Matplotlib is, right, what's actually happening here is it's rendering the plot every time I drag it and then sends the PNG to the browser, which is different from what we get if we use .hvPlot. So if we, just by importing .hvPlot.pandas, we're basically adding this .hvPlot accessor to our data frame. And now, instead of calling .plot, we call .hvPlot scatter, and we get an interactive bokeh plot. So that's pretty neat. There's a lot of affordances that gives us, right? We can now use the zoom tools. I can box zoom around. explore this data set like this. I can hover over individual data points to give me the exact coordinate, or if I were to say, basically, I can give it a hover column. I can basically say, I want to also see the magnitude. I can, that did not work. I think it's actually called mag. Yeah, I can now hover over it and I get the magnitude. And so already we get a lot of affordance just by doing this one import and changing .plot to a .hvPlot. Right? Pretty neat. It's a good start. So yeah, let's try as a simple, very simple starting exercise. Try that, just change, I just gave away the solution. You can give additional arguments to this plotting function. For example, to change the alpha, the opacity of your of each point, because actually, if you look at this, we're kind of massively overplotting here. Right? There's a lot of points in one place, and I can't really distinguish them, and so changing the opacity actually kind of helps. So just a second to do that. Another thing we can do is kind of use different plot types. This is actually, again, overplotting can be solved using different methods. One way to solve overplotting is manually adjusting the alpha. Another is to use a plot type that aggregates the data. So another one, we could, instead of using .scatter, okay, I'm again giving away answers here. Instead of changing the alpha, which kind of, now we actually see where there's a ton of earthquakes compared to, let's compare these two, right? We can now see that there's here in the Pacific West, there's a ton of earthquakes. Using different plot types, for example, a hexbin plot, we can aggregate our data in different ways to see the same detail, but using an aggregate. Right? And so again, you see here, the highest concentration is here. But one thing we lose here, of course, is we're now aggregating the data. We no longer kind of can hover and get information about each plot point, each point in the data. At this point, right, we've kind of, I've hinted to you, change the alpha. I've hinted to you, change the plot type to hexbin, right? But of course, to be effective, you kind of need to be able to figure out these arguments yourself. And hvPlot has various approaches to making this easier. One important one is just tab completion. If you're not familiar in notebooks, if you press tab, you access some object and then type something. You can do tab and the tab completes something for you. And if we tab complete on the hvPlot accessor, we kind of get a list of different plot types that are supported. Of course, it depends on like what is your data. We might not be able to generate a I don't know, OHLC plot, which is a way to visualize stock data. Doesn't make sense for this type of data, of course. But this lets you get help for different plot types. The other thing is for the arguments of a particular plot type, you can use hvplot.help. So if I do hvplot.help scatter, right, I get a list of kind of the core arguments. And in fact, we've mostly tried in hvplot to make sure that the .plot interface mirrors the .hvplot interface, right? So that all the arguments that you usually pass, except for a few kind of big size that's very specific to Matplotlib, that might not always work. But in general, we've tried to kind of keep API compatibility there. So here we can see, right, the core arguments here, X and Y for a scatter, makes sense. C is basically a color, if you want to color by a particular variable, right? We might want to do small df.hvplot.scatter x longitude y equals latitude c equals mag, and now we're coloring by the magnitude. And we get a color bar and all the other niceties of that. Right? There's a full list of parameters that are supported, and kind of it tries to explain a little bit what they are and what they do. We obviously won't go through all of those because that's a lot, but they roughly categorize into kind of the core parameters that specify what are you plotting, right? How do I map various columns or fields in my data set to visual attributes that you're putting on screen? And then various options that control kind of various things about the plot. Color limits, whether I want a color bar or not, various things about the axes, how large, how wide and tall is my plot, and so on. And then the other ones are Datashader options. We're going to get into that in a minute. Again, Datashader is about aggregating really large data sets, and we'll see that. If you've got GeoViews installed, which is kind of has a few more heavy dependencies because the GeoStack in Python is kind of a pain to install. But if you do have it installed, you can use these geographic arguments to kind of put a coastline in the background, project your data in various ways, and do a bunch of other things. Put some kind of a tile source in the background. And then there's here just a list of style options which control various aspects of your plot, line colors, and so on. Okay, so hopefully that helps. You also have the ability to kind of, okay, I want to only see some subset of the options, but yeah, play around with that. See, it's just a quick way to get information. Okay, next, let's again the first thing we did before we got into the plotting, right, was take a subset. We took 1% of the data here, and still we had a bunch of points on screen, right? Too many we were over plotting even with that 1%. And so that's where Datashader comes in. Datashader, we're now, here we're plotting the small data set. Again, we can enable Datashader simply by telling it to use rasterization, rasterize equals true. And what that does is basically take our data set, aggregate it, which means just compute an image, and we send that image to the browser, which means that no matter how large our data set is on the server, what we actually send to the browser, what we display, is much smaller. And so if we do that, you can see here, obviously the small data set still works, but if we do it with a large data set, we now have all the 2.1 million points, and on my local laptop, I'm bounded by the memory of my laptop, right? I can load probably about 1 billion data points onto this laptop. And the nice thing here is we still get the interactivity, right? We can still, if I zoom in, I can still scroll down to the individual data point, but at the high level, I get an overview of all the data. So we don't lose kind of the fidelity of individual points. What we do, because it is still an aggregate, we don't get kind of magnitude information about every point, but we get count information within each pixel. And so that's pretty neat. If I had 1 billion data points, this would still respond pretty interactively. One thing to note here is that I've kind of changed the color normalization. Color normalization is a pretty deep concept, right? If I, by default, you're used to using linear color maps, right? Not that nice. It doesn't really, okay, there's maybe 2-3 pixels with a ton of data points in it, and the rest is just flat. It's just using the same color. And so one approach to change that is to use log normalization, and now we see a lot more structure, right? We can now see clearly differences in magnitudes, right? There's 3, 4 here, there's 40, 50, 400 in this little pixel here. But if you have really weirdly distributed data, you can use something called Histogram Equalization, which kind of tries to make sure that for each color, points are equally distributed between the different colors. And so it results in a weird color map, and maybe you shouldn't use it to interpret things, kind of quantitative things, but it gives you a very, very clear idea of the structure of your data. So it's usually a good way to kind of do exploratory analysis. You've got this huge data set, you're trying to get an idea, the feel of the overall structure, and then after that you can kind of dig in and, okay, maybe log is enough, maybe even linear is enough, but it's a good way to get started. Okay, so in this tutorial we're focusing primarily on pandas. We're going to do a little bit of Xarray. If you have even larger data, we recommend using Dask. Dask basically lets you scale out your data frames to a cluster or multiple processes on your single machine. hvPlot works just as well as Pandas with Dask as it does with Pandas. So you, instead of doing import hvPlot Pandas, you just do import hvPlot Dask, and .hvPlot works just the same. We also have support for a library called Streams for streaming data. We have support for a library called Intake, which is very good for data catalogs. So you specify, I don't know, your organization has an entire catalog of data and you want to catalog it. Intake is a great solution there. We also have support for GeoPandas if you work with kind of geographic vector data, geometry data, and we have support for Network X for basically plotting graphs. You can check all of that out at hvplot.holoviz.org. All right, let's do something. Let's do a quick exercise here. We've got our larger data set. Let's filter our data down a little bit. So take only earthquakes with a magnitude larger than 5. Remember that the magnitude column is called mag. Filter it down, and then just change the color map. Let's start there and go from there. Give you a minute to do that. Oh, that's good. Okay, I'll give you another few seconds. So hopefully most of you have some familiarity with data frames, so this probably didn't present much of a challenge here. So we only wanted earthquakes with magnitude greater than 5. So we use the Pandas syntax to filter that. We then do .hvPlot, .scatter again. One thing we have to be careful of, and that's kind of a to-do item for us, is if you're working with this large data set and you forget to give the rasterize argument, you are going to crash your browser. So I should have warned you earlier, and hopefully none of you did that. So long it. Reds, and then rasterize. That's true. Nice. That is a very good point. In fact, I think someone brought that up the last time and we didn't fix it. Yeah, it's a very good point. It should have. It's a bug. Thanks for catching that. I think it's Yep, that's true. Well, that should also be the default, so I'm a little bit confused here. Yep, there's. Yeah. Good catch. All right, so let's keep moving. hvPlot has quite a range of plot types. We're not limited to so far we've seen scatter plots, fine. We have the ability to do statistical plotting, right? Aggregating your data. We're gonna here first clean up our data a little bit. We make a copy of our data, and then we're gonna only choose earthquakes where the magnitude is greater than 0, because you can't have a negative magnitude earthquake. But of course, real world data is not clean, and we didn't pre-clean it because we didn't. Well, yeah. To give you an idea. Okay, so again, you can use the Matplotlib interface to do this, and as you can see here, we can just the same. We can use .hvPlot to get a histogram plot. Maybe, yep. Let's give you a minute to do the exercise, which is just to generate a kernel density estimate plot. of the same data. And again, if you don't know how to do that, you can just do the tab completion trick and run that and find out which plot type you're meant to be using. Make sure to tell it which column you want to plot. We want a kernel density estimate plot of the magnitude. This is actually somewhat slow because computing kernel density estimates over 2.1 million points is not entirely trivial. Okay, so statistical plots, there's a number of types. Statistical plots is anything where we're aggregating data, right? We're doing some aggregation, whether that's simply counting the points, like a histogram, or doing a kernel density estimate, or yeah, you can do that in 1D, or you can do that in 2D. Actually, the Hickman plot we showed earlier is another example. Okay, so we'll move on. Let's actually deal with some categorical variables. So far, we've kind of plotted x versus y, where both are numerical values, but we have good hvPlot handles categorical variables perfectly well. We're going to use some Pandas magic to kind of create 3 different categorical classes. Right? We're going to create a shallow. We're going to split our data into shallow earthquakes, intermediate earthquakes, and deep earthquakes. Easy enough. We simply use the PD cut method on the depth column to find our bins, and then give it some labels, specifically shallow, intermediate, and deep. And now in our clean data set, let's have a quick look at it. It's always good to inspect your data. Should use head. We now have this depth class column in our data. And so to do categorical plotting by some variable, right, or we can simply pass this by argument, and because histogram plots aren't, you have to layer them or stack them, we're going to actually change the alpha so that we can see all 3 categories through here. This is one way to do it. Obviously, this is not that readable. So what you might try is, yes, we're going to still use the by argument, but instead of plotting it on top of each other, like we're doing here, we actually want them side by side. And so a simple way to do that is to use the subplots argument. So I'll give you a few seconds to do that. Oh yeah. It's one thing that's, because again, we kind of get the affordances of an interactive plot. We can show and hide the different categories. And so one thing actually that would be nice is if we zoomed in onto the categories that were currently highlighted, we can also control the alpha of the muted categories. So if I could in fact hide them entirely if I set muted alpha equals 0 and hide this. Now this plot is hidden entirely. So that's maybe a slightly hidden feature. And then we can zoom in and see the distribution of this class versus the others. So hopefully you've had a minute to do what I was just showing you. You can do subplots equals true. And then instead of overlaying them, we get them side by side. Maybe that's a little bit wide, right? So that's also a little bit narrow. So we'll just do 300. And now we get 3 different plots side by side. One thing that hvPlot does, or in fact the underlying library HoloViz does, to kind of be helpful, is it links axes together. So if I zoom on this magnitude axis down here, it's actually zooming on all these 3 axes. That's sometimes helpful, sometimes not helpful. In particular, it's also linked kind of the magnitude or the count axis here, right? We can disable that by saying link axes equals false, or well, that's actually not shared axes. Sorry, it's shared axes equals false. And now they're independent axes. We can zoom on them independently, and we actually see kind of the axes here. The axes labels are separate, so we can see kind of it doesn't show you the absolute comparison between these three categories, but we can actually see the distribution of them. Right, it's not squashed into a little tiny thing. Okay, we're gonna keep moving here. So grouping is another. So this is another superpower that's basically you're just not going to get out of dot plot, which is grouping. So grouping, previously we used the by argument to kind of group by some variable, but maybe we don't want all of these on the screen at the same time. Right? We've got a huge data set. We just want to see a subset right now, and so grouping, basically instead of using by, we use the group by argument. We're now giving you a widget that lets you change each category. And so here we're creating, again, another statistical plot, which gives you kind of a contour around the densities of these points. So here we're plotting depth against magnitude, and we're kind of looking at the distribution of these three, and we can use the widget to kind of compare. So this is helpful, particularly helpful if you're sliding through a huge data set at different times, right? I could have, yeah, it's very helpful to kind of explore larger data sets. And you can group by not just by one variable, but multiple variables, right? Here, I won't demonstrate that right away. We're going to now create another categorical variable, again, by using the PD cut feature, the Pandas cut feature to kind of classify earthquakes into different magnitude classes. So these are the official definitions of different magnitude classes. So we're going to classify earthquakes with magnitudes greater than 8 into great earthquakes, and then so on. Here's this table that tells us what this categorization means. And now we can basically do an aggregate over these and generate a heat map over these variables. Again, so we can work, yeah. hvPlot is very versatile. You can work with basically data of any type, and it has a wide range of plotting methods. So here, now we can kind of get an idea of what kind of earthquakes are most common and how deep are they usually. It seems like light and shallow earthquakes are the most common. So heat maps, again, are useful for comparing categorical variables, and we'll get into kind of other raster-like plots a little bit later. Okay, I've told you that, yeah, so Pandas.plot gives you the ability to generate Matplotlib plots. hvPlot originally was written basically to support only Bokeh plots, which is kind of, we work very closely with the Bokeh team. It just made sense to focus on that, and it gave you the ability to do kind of these exploratory and interactive plots. But in fact, more recently, we've now added the ability for hvPlot to also output Matplotlib plots itself, also output Plotly plots itself. So you don't need to necessarily switch back to the regular Pandas.plot. You can still use it to generate Matplotlib plots. And if you just like Plotly a little bit better than Bokeh because you like these, I don't know, just like the look and feel of it better, you can now also leverage Plotly. It's not quite as well supported, so you'll probably find a few more rough edges, but we're also working on addressing that. And so here, yeah, you can use the same plotting library to plot, the same high-level API to plot using all three different plotting libraries, which we think is pretty neat. Okay, so yeah, that's an overview of the various features in hvPlot. One other thing is, of course, you might want to save this. You can. One nice thing, of course, of notebooks, you can share the notebook. All the interactive features still work. Some features won't work. right? For example, Datashader in particular, every time you zoom in and out, it's re-rasterizing. Basically, the Python kernel is re-rasterizing your data. And so if you export the notebook to a standalone HTML file, it's not going to do that. But most of the other features, such as zooming on plots and all the nice features of Bokeh, you will still get in a static export. What you can also do is you can export hvPlot to different file types. You can export particularly to PNG and SVG. And you can do that for both Matplotlib and Bokeh plots. So Matplotlib, of course, supports outputting to PNG and SVG directly. Bokeh has a little bit of a workaround, which is it actually runs, it silently opens a browser in the background and takes a screenshot, which maybe is kind of crazy, but it works. So even if you want to do that, let's quickly do that. Here we're actually exporting the Matplotlib plot, so that's maybe not that exciting. But you can see here the hvPlot save method quickly lets you export any plot that you generated. So that also means you can kind of get access to a Matplotlib figure, and then you might be a master of Matplotlib, right? And so if you render your hvPlot object that you generated with hvPlot to a Matplotlib figure, you can drop down to the Matplotlib API and do whatever you want, right? You can use the neat little feature of using XKCD for styling with your Matplotlib output, and now we can generate a little plot in the XKCD style. And that goes back to the point we were making earlier. We always want to give you the power to kind of drop back to APIs you know. hvPlot's API is powerful, but it doesn't extend to kind of having tweaking every little thing about your ticks or whatever you want. And so if you want to do that, you can always use hvPlot.render to either render to a Matplotlib figure, or if you're using Bokeh, to a Bokeh figure. And then you can use that API to kind of do the fine little tweaks that you might want to. Yeah, that covers the introduction to plotting. Any questions at this point? Yep. That's a very good question. So in the past, okay, let's take a step back. So rasterized Datashader actually contains two components, right? It's a pipeline of things that you're doing. Rasterization just means aggregate your data into a fixed size pixel buffer, and then that means basically what you're getting out is an array of values, right? And so in the simple case, it's just count values at each pixel location. What Datashade does is take that and actually render it into an RGB image. And so you can do what you would usually have your plotting program do. You can have Datashader do basically color mapping. Right? Map a. Sorry. Oh yeah. What is that? Yeah, exactly. This is all back then. Okay, so where was I? So yes. So the shade part of Datashade basically means color map or color map it. Yep. Yeah, that's a good point. This also, however, means okay, where are we? This notebook has gotten pretty long with all this stuff. So yeah, I could switch here to from rasterized to Datashade. I also want to switch back to. I don't actually know how to switch back using. Sorry, I just need to switch back to Bokeh. Okay. So you can see here the plot actually looks identical. That's because we actually support all the color mapping options in Bokeh now that we used to only support in Datashader. But there's a caveat, right? When you hover, you get no information. In fact, I guess if I try and enable hover equals true, I could try, I'm not sure. Oh yes, what you get is this very helpful RGBA value, which tells you exactly nothing unless you're a machine, I guess. So we really, in most cases, we really recommend using rasterize equals true because it affords you, it gives you a color bar. You can actually, yeah, the actual data is still there. It's not just transformed into this abstract RGBA value. No problem. That's, yeah, I should have covered that earlier. I think I've forgotten.
One thing that illustrates is that we only added rasterize much later in the history, and we have lost track of our stuff. There's so much stuff on the web that says how we did it in 2017, and how we did it in 2019, and how we did it last month. There's just too much out there, and you'll find a lot of these contradictory, and the answer is usually that was the best way we do in 2017. Today, what you're hearing today is our best practice. 2022, this is what we really think is the right answer for those things. So we're going to present the things that are really we find that work well, that are understandable, that are powerful. You can look around and find other ways. They still work. We don't really delete things. But this is how we recommend it work because it's got the most power and the least learning, the least problem.
Yeah, so I've talked at you a lot. There was a few exercises there, but they were maybe not that engaging. So we're now going to do a little bit of a longer form exercise. So if you, in your tutorial folder, if you're using Classic Notebook, you'll have to navigate back to your file browser. 1 second. There is an exercise folder, and we're going to be doing the plotting exercise. I think, I don't know what the timings on that are. I forget. I think I'll probably give you a few minutes to kind of run through this, and then we'll quickly run through it together. If you have questions, I will be available.
The 15 minutes.
Okay. So maybe I'll give you.
10 minutes, right?
Oh, already after plotting.
After the exercise.
Yeah.
What is that? We wrote that.
I guess that was a pretty long one. Oh,
Yeah, it's been an hour, so let's have a little break. Anybody who wants to discuss what you've seen or had to call one of us over, like, I don't understand, why did you do it this way, or what is going on here, or what, anything like that, put a red sticker or raise your hand.
so for anyone watching at home, and maybe you guys, if you kind of go away from this and you still have questions and you don't know where you're getting an answer, you can go to discourse.holoviz.org. It's where we kind of, so just a forum to ask questions about any of these libraries, and we're always happy to help. Keep that up. How's everyone doing? Anyone done? How's everyone doing? I know that the last part, I realized I maybe should have gone through tutorial 3 first. So if you're not getting that one, it actually involves laying 2 plots on top of each other. And that was meant to be covered in section 3. But it's a good lead-in, right? So yeah, we'll be covering that in a minute. So I'll quickly go through this, right? How's everyone doing? Did anyone finish? Stuck? Good? Great. Saw a good number of thumbs up. So I'll quickly go through this. How are we feeling? Should we just power through the next one and then take the break? I think so. Okay. Yep. Does it actually do anything? Where is that? Oh, I think that's probably a leftover solution that should not have been in there. Oh, what it does, okay, I'll show you what it actually does. You can tap on individual points. And so in certain cases, That's helpful, in particular, if you're interested in getting the location of that point, and we'll show. I think there should be something later where we actually use that information. No, it should not. Yep. Okay, so pretty straightforward, right? This exercise is really about working with graded data. And so if you're not familiar with Xarray, again, it's very similar to Pandas, but for graded data. So here we have this 2D array, pretty large, actually 8,000 by 4,000 pixels. So that's pretty huge. See, most of it is nans. It gives you this nice little wrapper to kind of show you the coordinates and the actual underlying array. And this particular data represents the population densities across the world. And so that's interesting, right? So you have information about populations, you have information of a different type about where earthquakes are, and now you want to combine that information in some form, right? And so hvPlot, or the underlying library HoloViz, makes that kind of co-locating data or kind of plotting two things on the same plot pretty easy using this multiply operator. So multiply in HoloViz means put these things on top of each other. Right? And so that's how we get this co-located plot, which gives us kind of this population density map with the most severe earthquakes on top of it, and kind of here, if you're interested in kind of harm mitigation or whatever, you might say, oh, well, maybe it's not that, maybe don't put people right next to a fault line or whatever. So yeah, that's what we're going to be looking at next, which is tutorial 3, composing plots. And I think this one is actually relatively short, so hopefully we can go through it pretty quick and give you a little break. Okay, let's jump on in here. Again, we're just doing our imports. If you're RAM constrained, I would recommend at this point to go back to this previous tutorial and just restart it. Here, kernel restart. It'll clear out the memory that particular notebook was using. No reason to keep that memory. Will be, particularly as we go through these tutorials, you'll just be accumulating memory if you forget to do that. And similarly, yeah.
The actual schedule has one after.
That's what I thought, yes.
For anyone watching the recording, apologies.
Yep.
We're supposed to do plotting, then composing plots, then.
Yep. Sorry about that. All right, so let's jump straight into that one. I'm going to close this. Again, ideally clear previous notebooks, restart the kernel, and then start at tutorial number 3. Again, yeah, we're going to load our data. We're going to import hvPlot.pandas to initialize the hvPlot method. And the first thing we're going to do is resample our data. So here we'll get a weekly resample of our data and then plot that. So here we can now display that, and now we can see here kind of we get a nice time series plot. Again, the nice affordances of Bokeh we get right here. If we're zoomed out far, it kind of just shows you the years. If you zoom in, it has this nice daytime axis, which kind of gives you more resolution as you zoom in further. So that's pretty nice. So yeah, we have this one plot. And now we've always just kind of implicitly used the display machinery of the Jupyter notebook. We never really inspected what is this object that we're getting returned from these hvPlot methods. Right? We've always just kind of we've put that at the end of a line, and then we immediately get the output, and it kind of seems like it's just a Matplotlib, like Matplotlib, right, where it just displays inline implicitly. But actually, what we're doing here is invoking the display machinery, which means that this object that we're getting back from hvPlot is an actual object that we could, in theory, actually save to disk. We can do other things with. We can keep a handle on it, and then later combine with other plots. And that gives you a lot of nice affordances. And so actually, when we do that with this weekly count plot, we can see what is this thing? We can use print instead of just invoking the repr machinery. And now it tells us, well, this is a curve, and this is a curve of counts over time. All right, that's pretty neat. Underneath this, we're not going to dive too deeply into this. This thing is actually a HoloViz element, is what we call it. And elements are just different visual elements that you can compose together to generate your plot. Right? And elements have dimensions, and that's what these are. You can think of, usually we write this notation here gives you the key dimensions, or you can think of them as the independent variables first, and then the dependent variable second, or what we call value dimensions, or VDIMs. Okay, so again, now we're going to do a similar resampling, but for magnitude. Again, we can print that, and now we again see here we now have a curve of magnitude over time, and then we can compose this. Well, that's not really very sensible, right? We've done composing. We saw that composing in the exercise we just did. Well, that's not very sensible, right? We're now putting two different variables on the same axis. Instead, we can use the plus operator, in fact, to do subplotting, right? In Matplotlib, you'd kind of create your subplots and then insert your two axes into that subplot. In HoloViz, we have the concept of a layout, and layouts can easily be generated using the plus operator. And then we can decide how many columns do I want to lay this out in. I can do one column, so they're on top of each other. I can say, I think 3 columns is a default. So if I leave this out, it's just going to put them side by side. I could, if I made them slightly smaller, you actually have them side by side. And so composing plots in this way gives us, the ability to you can generate a plot. You can then decide, well, do I want to overlay that? Do I want to combine it with other plots? And so the affordance of having these objects that are returned by hvPlot is that we have this compositionality, right? Each component is separate, and we can later decide, I want to put this on top of this, I want to put an annotation on top of here, I want to put them side by side, and so on. So that's kind of related. So this is kind of a diversion here, and we actually saw this before. We put 2 dimensions side by side. We plotted magnitude and the weekly, magnitudes side by side with the depths, or actually just counts of the earthquakes, sorry. Another way we can treat dimension is by mapping them to some other feature of our plot. So here, as we saw before, we can just use C equals magnitude, and this works just the same as it does in Matplotlib. So we can color map, we can do things like map it to the size, actually scale times 10 or something. But yeah, we can, additional dimensions, we can map onto colors, sizes, and whatever else we want. In fact, there's an entire system for kind of mapping columns in your data onto visual properties on the screen. And if you want to dive a little bit deeper into that, there's an entire user guide in the HoloViz section about that. I won't cover that here. But again, if you want to dive deeper into some of these systems, you might want to actually look into HoloViz itself. Okay, again, now that kind of we're plotting the scatter of longitude versus latitude, and we've added this extra dimension, you might have already kind of seen we have this distinction between scatter and points. Here, this is a little bit weird, right? Actually, it's like I was talking about independent and dependent dimensions before. Because HoloViz and hvPlot are declarative libraries, you're actually declaring something about the semantics of the different dimensions of your data, right? And so when you're declaring something as a key dimension or independent variable, the latitude doesn't depend on the longitude, right? That doesn't really make sense. And that's why we kind of have this distinction between scatter and points. So if I do that here, we actually get a points object where longitude and latitude are the independent dimensions, magnitude is the dependent dimension, and conceptually that makes a little bit more sense. And that's actually important in certain cases where HoloViz kind of infers things about your data for you. We'll see that a little bit later. Brief interlude. So we kind of looked at color mapping here. Color mapping is a really deeply complex field. In particular, color maps. There's lots of arguments about color maps. In fact, I think one of my favorite SciPy talks is entirely about color maps. Years ago. And I think that's when the tide started turning against JET in particular, just how harmful it is. And so ColorSet is a library that we develop, or in particular Jim. I think Jim is actually the only person who's been working on that. It ships with a large number of perceptually uniform color maps. And perceptually uniform basically means that there's no weird kind of, if you made this black and white, you would not have weird changes in brightness, right? So here, you can see here, it goes very clearly from very dark to very light, and that's one of the main issues with JET, right? If you plot it to JET, the brightness of JET as a curve, you see weird jagged edges all over the place, and that's really not a good feature for interpretability. And so if you're interested, well, you should be, ideally, you should be interested in plotting your data accurately. Ideally use perceptually uniform color maps. Matplotlib now provides nice ones like Veridis or Magma, and I think there's a third one. But ColorSet provides a whole range of other ones that might be to your liking. And it also has various nice ones for kind of large numbers of categories and so on. And so you can use that. You can use that in place for when you're doing the CMap argument in your hvPlot call. You can just provide it with this color map here. And yep, that's the end of that. You might want to kind of get an idea of the different ones, use the swatches argument, and then it'll present you with a range of options for different perceptually uniform color maps. Okay, let's look at that together. There's a warning. I'll have to get rid of that. Yeah, so yeah, it really ships quite a few. It even ships ones that are very suitable for kind of accessibility, for color blindness and so on. So here you can see Protonatom. I probably can't pronounce these. But yeah, it has a wide range of them. And yeah, if you care about accessibility, which you should, it also has great ones for that. And so let's see what that looks like when applied to our data. Yeah, easy enough. You can even refer to them as strings. You don't necessarily have to import from ColorSet, blah, blah, blah. As long as you have ColorSet installed, it'll try and find it from ColorSet. So the supported ones are everything that's in Matplotlib, everything that's in Bokeh, and then if it can't find it in those, it'll try and look it up in ColorSet. Okay. If you're working with geographic data, you often want context, right? So these plots here, great, white background, doesn't, like, okay, I can sort of guess, well, just because we plotted the whole data, we can kind of guess where everything is. We can kind of here see the Pacific Ridge, I guess, and here I guess this is the Pacific Ridge, or the Ring of Fire is around here. But in many cases, you won't be able to guess the context of this, and so you want some some context for your plots. And using the composability, you can import various tile sources from HoloViz. From HoloViz elements and tiles, you can import, for example, this Esri tile set, which is, kind of, if you're familiar with Google Maps, it's just tiles. The further you zoom in, the more resolution you get. And so if I just compose that, we now have a nice plot with the actual background, which gives us context. And so I don't have to guess that this is here, the Pacific coast, for example. I can see it directly. Again, you don't actually have to import if you get used to this a little bit and kind of know which tile sources are there. You don't actually need to import the tile source from HoloViz. You can just request it. I don't know. We should have a. Oh, that actually worked. Oh yeah. So it has nice error messages if you kind of want to guess one. It gives you a list of available color maps, available tile sources that you can use to give context to your plot. And there's quite a few of them. So yeah, if you need more, so here, if you actually inspected the data, you'll have noticed that we're cheating a little bit here. Oh no, actually, in this particular case, we're not cheating. Wait, what? 1 second. Longitude. Oh, I'm surprised. Oh, I guess we have GeoViews installed. Yeah, yes. Oh, yes. Okay, yes, that's precisely right. So if you're kind of work with geographic data, again, we've mentioned before that we have this GeoViews package, which lets you deal with different projections. And so in particular, here, you'll see that we have this duplicate columns in our data, one of easting and northing, which is this weird number, which actually is, I think, meters from the null point, null island, somewhere here off the African coast. And so that's what, if you want to plot things on top of a tile source, you need to convert it to Mercator. We've done that manually here. If you do that often, we recommend you install GeoViews, which will actually, you can tell it this is in this particular coordinate system, and then if you overlay it on tile source, it'll know, I need to project this first to this other coordinate system to overlay it. And so that's what GeoViews gives you. It has some other functionalities, but yeah, that's the core of it. It basically wraps a library called Cartopy, which is kind of the recommended projection system for Python these days, and also when you're working with Matplotlib, that's the standard these days. So yeah, I'll give you a second to play around with some different tile sources. Remember, if you mistype one, it'll give you a nice list of them, so you don't necessarily have to import them.
That's a general trick to try if you don't want to try to look for the manual and mistype something. Usually an error message tries to.
And if it doesn't, you can complain to us.
Yeah, there are places where it could, and we don't have that. That's a valid feature. Because it's super helpful in where it is.
So I recommend just copy, paste, change it. And there's some fun ones, I think. Yeah, go. Yeah, so hopefully you've done that. Oh, that's not correct. So here you can see what happens if you.
Oh, yeah, this is a good learning experience here.
Yeah, so here we've plotted longitude and latitude on top of our tile source, and they're in completely different coordinate systems. And now we have all our points are now centered around Null Island. And Null Island isn't actually real. It's just what we call this point in the just off Africa. So yeah, if we zoom out here a little bit, a lot, we can see.
If you ever find all of your points and land in that one spot near Africa, you realize I need to reproject into this map source
Okay, so here is, well, I think we're not going to learn much new here because we already did the exercise that we were meant to do a little bit later. But yeah, we're going to load this data set of the population density again. Yeah, we're going to clean it up a little bit. Briefly about Xarray again. I told you multiple times now, it's like Pandas, which means that if you're used to working with like images in NumPy, you're working in completely abstract coordinates, right? You're slicing column row 10 to 50 or whatever, and it's totally abstract. But usually, your image actually has coordinates. There's a real world unit to the different coordinates, right? And so the nice thing about Xarray is that it has methods to, for example, slice. I want to slice the y-axis for latitudes between 10 and minus 10, and I want to slice along the x-axis from 90 degrees to 110 degrees. It actually lets you work in those coordinates, and that's really, really nice. So again, we're going to rasterize our data set. If you see this warning, we're, I think, trying to get rid of that. Yeah, we can plot it. We've done that before. We can see, again, here, this is something I won't go into too much detail about, but whenever we have kind of some really interactive element, what's actually happening here is that as I zoom, right, we're sending back the bounds of this plot back to Python. Python then re-aggregates our image and sends it back to the browser. So there's this loop here. And to handle that in HoloViz, we have these objects called dynamic maps, which basically are wrappers around a function, which is given the bounds of our plot. The function then returns a new image that is then rendered. So we can always inspect the contents of this thing just by accessing .last. And so here we can now see the current, basically the current state. Yeah, so basically here, this is now a static thing, right? This dynamic dynamic map thing, reevaluates whenever the zoom extent changes. When the access .last, I get the last state. This is a static thing. It doesn't re-render. So if I zoom in further here, basically I get more pixels. I don't get more information. Which also means if I zoom out, it's just white space. Okay. Yep. So finally, let's put all of the things we've learned about plotting together here. We're now, going to plot. We're going to plot our rasterized population. We're going to plot our high magnitude points, the most severe plots, overlay them, give it a nice background, and now we get actually, this is kind of closer to a plot that we might want to share with someone. Right? Obviously, there's many more customizations we might want to make, but this kind of gets us to a good place. Oh, that's a good question. It's not even working, right? Really, we should have. I think this is from. Unfortunately, we keep reusing this tutorial, and so it seems like it's just not. Okay, I should have applied it here. I won't go into too much detail here. That was just left over from an earlier thing. The basic idea, just not to divert too far, but relabel is a method for HoloViz, so it's one level deeper. You can relabel objects, and in theory, it uses those labels to label our plots. It looks like, in fact, we also use information about the dimensions of the data. So in particular here, this clean data set, I think, had this band dimension, and that takes precedence over the label when you're titling a plot, and that's why we ended up with that weird title. So sorry about that. It's another thing to fix I think. Maxime, can you keep a list of all the fixes? Thanks. That's true. Okay, so yeah, that's much closer to where we want to be. So here you can see again, when we're composing, we're kind of generating these complex compositional objects. And hopefully one thing you've taken away from this, right? hvPlot kind of focuses on this very, very high level thing. We start somewhere, we generate a plot very quickly, we add a few options, and we get kind of from point A to B really, really quickly. We can go pretty far. Right? We can get nice plots, we can get interactivity, we can get widgets, we can plot these really large data sets, but maybe I can't tweak every little bit about my plot. And so very low level, if you really need that, you can drop down lower, and that's why we kind of, the schematic kind of highlights our approach, right? Most of our tools are very high level. You can always drop down to the lower level, and so we have this layered approach where, you go from point A to B really, really quickly, but then to get to your final destination, you kind of drop down to this lower level and do the final little tweaks in some lower level API thing.
The important part is that as a newcomer to it, you start off at high level. If you get to the right spot by the high level, you're done. You never do anything else. If you say your boss really needs this thing to move over here, you learn in that little local area. You don't have to learn all the steps. You only have to learn the difference between where you got with the high level and where you need to go. So you learn that. You look up. How do I change tick label? Focus on that, and you really that's what that one detailed thing is about. The one thing you want to change. You don't learn everything else today, or maybe ever.
Well, that's also, the other nice thing is, right, that's not something you remember. Even if you used Matplotlib for the 10 years, you're not going to remember every argument to n tick label formatter, right? That's never going to happen. You're still going to be looking that up. And so you get from point A to B quickly, and then you're going to be doing what you've done anyway, which is nice. So that's a little bit about the philosophy behind our tools. So that covers the plotting section of this tutorial. Next, we're going to dive a little bit into kind of how do I make my plots more interactive? How do I add some widgets to my interactive pipelines and so on? And that's where we'll go next. And then finally, in the last section, we're going to cover how do I go from these plots and a few tables into an application that I can share with someone else. Cool. So we'll take how long's the break? Yeah, 10 minutes. All right, let's get started. Before I continue, I'm just going to show you quickly what we're working up to. So we're trying to build by the end of this, we're going to try and build a dashboard, right, or a little data application. And so that's what this is going to look like. It's not the cleanest thing. I'll show you some other nicer looking dashboards in a minute as well. But yeah, the basic idea is that, we're going to kind of add some widgets to our plots. We're going to combine things together, add some deeper interactivity where we're clicking on a plot and some other plot updates. And that's what we're trying to lead up to, right? And so here we have a nice little panel application. We have our header area, we have our main area, we've got our little map. That's the first component that we've already built, right? That's what we've been building up to so far. And now we're going to be adding some more components here to kind of add some interactivity and then add some deeper, richer interactivity. So here, for example, have the ability to click on a particular point, find all the earthquakes near that region, plot their magnitudes over time, plot a histogram of the magnitudes of earthquakes in that region. For example, be able to kind of link the color map on the left to some widget, or kind of the distance around which we're searching for earthquakes. So we clicked on a particular point, and now we're going to kind of plot all earthquakes near it within a 1.5 degree distance, or a 0.8 degree distance, or even tighter. So yeah, that's the rough thing what we're going to be working up to. For kind of just a general idea of more of the kinds of applications you can build with Panel, you can go to examples.pyviz.org, which has kind of a whole set of different examples with different use cases. You can check that out. So some other ones might be this dashboard visualizing the penguin data set, which I don't know if you're familiar with, but it's just information about various penguins. And here we have things like linked selection, so we can select on this plot and all the other plots update, that kind of interactivity. Or this example here, which is basically optimizes a stock portfolio. A little boring, but there we go. We can click on the plots and kind of see, compute various things about what is an optimal portfolio and so on. We have different components. We have widgets on the page. We have tables on the page. We have different tabs for different data. That's the kind of thing we kind of hoping to build by the end of this, right? And yeah, you won't be masters at it, but you'll have the rough idea of how to go about building these things. All right. So the next thing we're going to jump into now, let me find this, is this notebook here. Again, don't forget to restart the kernels in your old notebooks, just to free up some memory. All right, so we're going to jump into this number 4, interlinked plots. And so you saw some of that already. How do I link a selection in one plot to the selection in another plot? Well, there's inbuilt functionality to do that. So let's start by, again, we're going to run our imports. This is the first time, I've done it a few times, but this is the first time we're going to import HoloViz directly. So we're going to use functionality that's currently present in HoloViz. We might expose that functionality directly in hvPlot eventually, but here for now, we're going to invoke that directly. So again, load our data, select our most severe earthquakes, and now we're going to show you how to do link brushing. And I'll explain what link brushing is in just a second. Okay, so let's start by, we've created 2 plots, right? We've created a plot of, a histogram plot of the magnitudes again. And we've made that responsive, so just resize this to the size of the screen. We've created a histogram of the depths. And now we're going to compose those together into a layout again, using the plus operator. One difference here is we're going to make an instance of this linked selections object from HoloViz. And so we'll show you what that does in just a second. So yeah, we now have these 2 plots. We already knew kind of it links axes together if they're the same axes. Right here we have separate axes. But what this linked selections thing does is it actually links, it inspects these 2 objects. It finds out they're coming from the same data source. So we're plotting 2 different columns of the same data source, which means that if I select on one plot, it can go back to the data source and actually select those same points, those same rows in the table from in the other plot, and then updates the visualization in response. And so here we can really dig into this. This is really a superpower to dig into really complex data sets with 30 columns, and you're trying to figure out kind of what are the relationships in this data? How does magnitude affect depth, or deeper earthquakes? So I can reset here. So I'll explain a little bit about kind of what these selections do. So let me select here. I'm going to select deeper depths. You can see here, kind of, it's a little bit hard to see because we're selecting just a subset, and so histograms are not the best at showing the absolute frequency of these. So I'm going to zoom in a little bit here. Other things we can do here is we can select how do I combine different selections, right? By default, every time I select something new, it replaces the previous selection. What I can do also is do unions of selections. So if I do select here and then hold shift, I can also add a second selection to that. So here I'm selecting low and high. For example, I can do things like exclusions or unions, right? Or intersections, sorry. So for example, if let's again start here and here, it's now going to take the union of those. If I take the difference instead, so I start here and here. Oh, that's not the right behavior. So sorry, demo effect. I think I did something wrong here. I didn't setting it up, but yeah, that's the general idea. I'm not quite sure why it doesn't work in this particular case. So, and if you want to reset it, you just click the reset button, and it resets it for you. In this particular case, it's also showing the lasso select. It probably shouldn't because it doesn't really make sense to do a lasso selection on a histogram. It's more for you selecting scatter points or whatever.
Just to be really clear, like, what if you wanted to know what is the distribution of magnitude for depth greater than 600? What would you do?
Depth's greater than 600. Let's select here. Right. Oh, actually, I'm taking the difference in this case. So let's try that again.
So that's showing that for the depth greater than 600, how does this other variable behave? Well, it looks like there's not much data there, and it's fairly evenly distributed across magnitude.
Yeah.
So you can pose virtual experiments like that. How does this portion of this dimension relate to any other dimension? You can go back and forth with some data set. This is what I do. You can have any number of plots looking at a 50-dimensional data set. You can have 50 plots. And each one you pose a little question. How does this relate to that? You select the thing you care about, and you can see how it relates to everything else. Without any coding, without any, just to explore any variable
Yeah.
against any other variable. Not just any variable, but any portion of any variable. Anything you can select, any chunk. The highest value of this, how does that compare to the low value of this? So of the high values, what about the ones that are low in another dimension? How does that relate to the third dimension? You can just sit there all day without coding and
Yep.
explore complex multidimensional data sets.
Yeah. So if I were to interrogate this myself using code, right, I'd be here for all day. Like, do this experiment. Well, for magnitudes greater than 600, plot this, and then reevaluate, and you're there forever. This is just a very quick way of going about that. And the more complex your data set, the more complex your plots, the more difficult this gets, right? And so link brushing is, it kind of automatically figures out how the different columns are linked, goes back to the original data set, finds, does this column exist in both these tables, and then it replays whatever transformations you've done on top of that. So here what we're doing, right, is taking this geoplot. So we're, again, just doing a points plot of eastings versus northings, putting that on a map, and then doing the depth histogram. And so now this probably actually makes more sense to you. The previous one was kind of hard to, does depth relate to magnitude? You might not really grok that, but here this is maybe more interesting. You could, for example, say, let's say in the specific region, particularly over Japan, what is the distribution of depths versus what is it in a region like this? And again, well, yeah, I don't know if there's, the problem is there's probably nothing. So this works really probably better if I did this with the larger data set. And we're hopefully going to see that in a minute, or otherwise I'll live code it up for you. So this is a pretty quick tutorial. It just shows you how to link different things together. And I'll briefly, actually, just out of interest, I'll briefly code up the full data set. So df.hvPlot, points, easting, northing, rasterize equals true. So we're now working with the full data set, right? So that makes it a little bit more interesting. We're again just gonna copy the histogram from here, magnitude histogram, swap that out for the full data set, responsive equals true, do one plus the other, and then add the link selection on top. One. Okay, that's going to take a little bit longer. Ooh, that's not that pretty. I also want to add the tile source, right? tiles history, I guess. Oop. Make it a little bit higher. Okay. Oh, and also cnorm equals eqhist. Okay, so now we have something that's interpretable. I can zoom in a little bit. And now we can still, so now let's, here on this histogram plot, just select earthquakes with magnitudes greater in this particular region, or this region. And so yeah, now it still works, right? This is the really neat thing. Because HoloViz does all this tracking of different information, these objects know what data set they were derived from. It can track the data set entirely through this pipeline of operations that's being done. So in this particular case, the operations are computer histogram or rasterize this data. When I do a selection, it takes the original data set and overlays that with a different version of that data set with this new selection applied to it. And so we can actually inspect what that looks like. So underneath this all lies so I'll look at that, a so-called selection expression, which basically gives us an expression of what the exact selection we've applied is. Right? So in this particular case here, I've done a selection from a magnitude greater than 2.67 combined with a selection of magnitudes less than 4.79. And if I also add a selection on here to it, right, we now have a combined selection of both of these things. The expression becomes larger, which also means that we can access the current selection in Python. Right, we have the selection expression. We can apply that to some data set. So I can say, filter the most severe earthquakes. Well, in this case, there's nothing in there because we've kind of selected out the most severe ones already. So we're going to apply that to this data set. And now we get back, we can basically filter the data set by the selections we've applied. So now you can do other things with it. For example, I could do something neat like basically show a table of the current selection I've done in our application.
I think we should take a breath for a moment because what he just did here is switch from a talk about plotting to entirely different universe with all the analysis you can do using the same tool. It was always there, it was always underlying everything you showed in the first part of the tutorial. That was all about plotting. Really, it was about constructing objects that can be used as plots. You can also do a lot more with it. That's again the shortcut's not dead end. Those things that you constructed when you made a little scat plot, that wasn't just a feature. It wasn't a pretty thing that you see. That was an object. It has a visual representation, but it has lots of other things you can do. You can overlay it on top of things. You can play it out. You can select. You can actually get into the data underneath it. You can do things like this because you've captured and described what it is you're doing. You can actually go way further. And then what this is doing is going zooming completely out of plotting into an entire type of data analysis. And sorry to throw that on you. But that's what these tools allow.
Yep. And in fact, that's kind of the direction where we're going in from here. We're now exactly making the transition from plotting, just put something on the screen for me, it looks pretty, it kind of gives me some idea, to analysis, to kind of digging deeper, getting to grips with our data set, drilling down and kind of understanding the data set in different ways. And so, yeah, linked selections is one way to do this. It provides powerful, it magically does this for you. You can do a lot of these things yourself in theory, right? But the linked selections component really makes that easy. Yeah, you had a question? Yep. Oh yeah. Okay. Drawback of this, of course, of live coding is that you guys don't have a copy of this. Absolutely. That's smarter. All right, everyone has to look away for a second because I'm my internal Slack. Yeah. It was half a second, so we're okay. Is this the right one? I don't want to do that.
Oh, I should acknowledge our colleague, Jean-Luc, who is still in Europe. He wasn't able to make the trip. He's helping out online, so I see he's chiming in.
Yep.
So thanks, Jean-Luc.
Okay, yeah, there it is. That was a smart way to do it. Okay, so that was a quick little section, but hopefully it kind of revealed some of the power that these things give you, right? We're not just plotting, we're not just throwing our data at this plotting program and having it plot it. We're actually declaring things about our data that then this program, this library can use in various other ways. Okay, again, constant reminder. Oh, actually, we have an exercise. Yeah, the basic idea is that filter basically applies to any data set you give it, so you can do your own selections, use the filter method, and it will subfilter it just the same. So we have this abstract expression which basically captures our selections, and we can apply it to any data you want. Okay. Finally, make sure to restart your kernel. Keep reminding you. Okay. All right, yeah, now we're making a pretty drastic switch. We'll still be, I think, plotting a little bit, but now we're getting into the realm of interactive pipelines, interactive exploration of your data. And so that's kind of a separate thing. And so we're also, this is the first time you're going to be introduced to panel, and so that's where we're starting here. Okay, so first thing first, we import panel, we load the extension. Previously, when we used hvPlot, it was loading an extension for you automatically, kind of hvPlot, import hvplot.pandas, or import hvplot.xarray. Basically initializes the extension for you, loads all the components, JavaScript components for you. If you're working with panel directly, you need to do that explicitly. And similarly, if you're dropping down to a HoloViz, you also need to do that explicitly. Okay, so panel, again, is a library for building applications, dashboards in Python. It's optimized for use in notebooks, but works equally well in a kind of IDE. So there's workflows there, which I won't cover in detail. Maybe at the end, if we have some time, I'll quickly demo what that looks like, because it's an important workflow. In fact, one thing I might quickly demo is the more powerful workflow for building applications in the notebook. Okay, so you might be familiar with SciPy widgets. This is, in effect, pretty similar, right? We instantiate a widget, we get the widget object, and if we put it here, it'll render itself. And so when I drag this, it sends the current value back to Python. We can access it on the value attribute. And if we set it from Python, similarly, it syncs it and updates the widget state on the front end. Yeah. So yeah, try playing around with the widget, see the value respond. Yeah, so as I drag, we always have this interactive loop, and now let's actually connect that widget to something, right? Widget on its own doesn't do anything, it just reflects the value to Python, and now we can connect it to something. And now we're again going to load all these different libraries. We're going to load hvPlot, and we're going to do some transforms on our data, right? We might do something simple. Actually, I think we probably did it before. We're going to select the data, only data points that are greater than 5 in magnitude. Simple enough. Yeah, that's pretty straightforward, right? But what if we could, instead of manually having to kind of retype this, say, I want magnitudes greater than 5, magnitudes greater than 6, kind of adjust it manually to get the right number of points, or I have some other criterion for what I want to do, what I want this data to look like. Instead of that, we use .interactive. .interactive is kind of another magic thing which turns your regular data frame into an interactive object that now allows you to, instead of kind of having hard-coded values like 6.2 greater than 6.2, I can actually substitute the slider here. So I can say, actually, I want to filter my data with the magnitude slider as the maximum magnitude value. And now if I drag the slider, it automatically reevaluates our data pipeline, and the output gets updated. And so, yeah, in this way, we can kind of start building interactive pipelines of arbitrary complexity, insert widgets at any point, right? I might say, well, actually, that's probably the next example. So in this particular case, the output here is obviously just the data frame, and the data frame has a nice wrapper in the notebook, and so when I update it, we see the output update here, the table update, but in fact, any object being returned by this interactive pipeline will get a wrapper, it'll get displayed. If I drag it, for example, I look at the shape of this data, instead of seeing the table, I now see the shape update. Similarly, if I want a Matplotlib plot as output here, I want to see a Matplotlib plot of the magnitudes, of a histogram of the magnitudes. That is now the output. Every time I update the slider, the plot updates. And of course, this works just the same if we substitute the Matplotlib plot for a hvPlot. So that's pretty neat, right? We start with kind of code that looks familiar to you. If you know, at least if you know the Pandas API, you've seen slicing before. If you know the .plot API, you've seen plotting before. But now, instead of kind of being fixed by what you've done, what you've typed manually, you can just substitute various arguments for widgets, and you get an interactive application out of it. So let's try something different. Here we have a date range slider. So far we've kind of filtered by magnitude. We might want to instead filter by a particular date range. A date range slider, yeah. That is a very good point. It, in fact, as long as I implemented it correctly, it should cache everything up to the point where the widget is injected, right? So let's say you've got a 10-step pipeline, and somewhere in the middle, your widget does something, like, I don't know, filter something. Everything up to that step 5 should be cached. It then filters, and then obviously it has to rerun the rest of the pipeline because it's dependent on the value of that. Yeah, so here we have this date range slider. For panel widgets, which makes it distinct from any other panel component, the value is always the current value of the widget. And so in this case, this date range slider returns a tuple of timestamps. And so if I drag it, the timestamps here update. Ooh, that is not quite what we wanted, but I guess on initialization, we get the Pandas type, and then afterwards, it's just returning regular date times. Internally, those are interchangeable. Yeah, we can now, for example, create an F string that formats these nicely so that we get start is at this time and the end is at this time. And we're going to use that F string a little bit later on. But now we're going to combine our two widgets to build a little bit more of a complex pipeline, right? In this case, all we're doing is filtering still, but we're filtering by the value start, by the value end, and this now gets into param. I told you earlier I wasn't going to dive too deeply into param, but this is one concept that you really need to understand to get an idea of how things work here. So previously what we did, right, was just, I was saying deify magnitude is greater than the magnitude slider. What this really in effect is saying is the value parameter of the magnitude slider is greater, or is greater than this. Yes. So let's see what that looks like. In effect, so all parameterized objects, such as panel widgets, have the concept of, so we have this max slider and we have the current value, right? But we also have the concept of a parameter, which is basically effectively saying this is a reference to the value at some future point in time. Right? And so when we're using this parameter value, we're effectively saying to this interactive object, when this parameter changes, query the current value at that point in time. And so when we're saying magnitude is greater than the magnitude slider, we're saying watch the value parameter on this magnitude slider, and when it changes, look at the actual value at that point in time, and then reevaluate the pipeline with that current value. Oh, yes. That's great.
This is a shorthand. When you leave off out parameter values, that's what it means. You say max slider 2, and there's only one value, it means the value parameter of your slider. This slider is a scalar, it's only got one value. You don't have to bother to type that extra stuff, but it's there.
Yes. And that's just because widgets and panel basically have one canonical value, and that's what distinguishes them from other components, which means that it's perfectly reasonable to say, well, whenever you reference a widget, what you actually mean is the value of that widget, or the parameter that represents the value of that widget. And this is important in certain cases, right? Widgets actually have a whole bunch of parameters. So for example, if I, again, tab complete, right, there's a whole bunch of parameters we could depend on here. Most of these obviously don't matter to you, but in this particular case, right, we're filtering by this, and we're trying to do two separate filters, greater than and less than, and so we need to reference these two parameters separately. And so we're saying greater than the value start parameter and less than the value end parameter. If I did doing param value wouldn't work because you can't compare the index to a tuple, which is the actual value. Okay, so yeah, here you can see it still works. We can both of these widgets work to control this. I can scroll through time. I can still filter by magnitude. And yeah, we can build complex pipelines in this way. Jim, you made us do the exercise before we were meant to. Yes. So the exercise here is basically doing what we just already did. So let's do the second exercise, which is try filtering a subset of the columns. And this is maybe a little bit complex. You might have to basically decide. I'm going to give you a hint, basically, is the idea here. We want a widget that allows you to select between the columns. And so a good widget for that might be the multi-select widget. And select widgets always have a set of options. And so we might want to say, let's create a widget that allows us to select between all the different columns. And we might give it a fixed height, like 400, let's say. Well, that's a bit high, 200, 150. Basically define this and then basically use the interactive DFI object to filter the columns that you want to see displayed. This does presuppose some knowledge of Pandas APIs, but hopefully that's okay.
Maybe to really take a step back here, we can think of this as leading towards a dashboard. Sure. We can also think of this as getting your job done today. You're just sitting there, you're exploring some data, or you're trying to answer some questions, and you don't want to type it in. As easy as this. You make a widget for the one thing you want to explore. Whatever you want to explore, you can express it as a slider or a selector or a choice of some sort. There'll be a widget for that. Find that widget, get a copy of it now, stick that in your little analysis pipeline, and get your job done. And delete it when you're done. It doesn't have to be leading up to a big app that you deploy and share and maintain. It doesn't have to be any of that. It's just you getting your job done today. Whatever you're trying to do.
Yep.
So here, you're kind of focus on the machinery while you're doing it. Hopefully, once you're able to do this, you can forget the machinery. Go back to thinking about my data, my questions, my research. The idea is this should just be a line or two of code, and then you get to your data, your question, your research. That's the goal. And it's easy to get confused while we're doing this. Try to keep that goal in mind. I want to have power. I want to have the power to explore whatever I'm doing. This gives you that power.
Yep. Typing is painful. Basically. If you're constantly changing parameters, you're there all day. Okay, in this particular case, it's really quite simple. The answer was simply index your DFI with the selection widget. Again, you could have done, if you want to be fully explicit, you can filter it by the param value, and this will let you select multiple columns, right? Or well, it should. A little bit confused by that. Okay, must have done something wrong here. Great. Oh. Yeah, that's actually an issue, I think. Maybe it wasn't quite as simple as I thought, particularly because, well, we'll see that in a minute. And actually, that's a good lead-in to my next point. Often, in certain cases, the widget value doesn't directly map onto the argument that you want to pass to your data pipeline. So for example, in certain cases, your widget returns a tuple, but the arguments expect a list, right? So that's a problem. And how do you get around that? Well, you can use functions instead. And we're going to see what that looks like now. So let me just think about this particular. Oh, okay. Yeah. So here we now have a select widget that selects between different types of earthquakes, or basically different causes for types of earthquakes. Just regular natural earthquakes. Someone blew up a big quarry. There was an explosion somewhere. I guess a glacier collapsed. Those are all different causes. But now you want to map that onto something else. I don't think this is a particularly good example because in this particular case we're actually filtering directly by the type, but let's ignore that for a second. So here, the input function basically is we're starting with some data that we could also be starting with some data that comes from a REST API or something, and we have various widgets as input. In this particular case, you can imagine, let's say, yeah, we wanted to kind of query from a REST API all regular earthquakes, all the quarry blasts, and so on. And so we start with defining this function, which fetches our data from somewhere. In this particular case, it's just fetching it from this data frame that we already have in memory, and then filters it. But you can imagine this is a requests. I don't know. You're using requests in here and fetching it. You can use that as a starting point as well. So here, what I'm doing is I've defined this input function, which grabs the data from somewhere, and is then given this argument, which comes from this widget. So here, I've got these various event types that I'm selecting from. I'm binding that widget to this function, and so that whenever this widget changes, this bound function gets called, it reevaluates it, and we're kind of filtering the data in this way. And so basically, instead of having a data frame as a starting point, you can have a function as a starting point for your exploratory pipeline. And then you can still call interactive on that and have that as a launching off point. Right? And so here, yeah, we've kind of done something to fetch our data with various arguments that have come from these widgets. We've turned that into an interactive pipeline. And then we can, again, use our magnitude filter to filter that data that we've just queried. You can imagine, yeah, I could now, whatever is happening here, I could now be basically filtering, fetching that in this function from somewhere. That's particularly interesting. Another use case for this, right, is you've got various data sets on disk, or a bunch of CSV files on disk, and you want to explore all of them. You just basically get a list of all the file names, you put those as options into your select widget, define a function that loads, basically just Pandas read CSV or read Parquet or whatever, and now you can explore an entire folder of CSV files very easily, right? And still have your interactive pipeline chained after that. Yeah. As we already saw before, interactive in HoloViz works just fine. Right? You can have your interactive plots chained into your interactive pipeline, and the other nice thing about this, right, is that interactive pipelines can branch off. Right? You can have here. I think before we defined our filtered pipeline. Yeah, up here we kind of defined this pipeline up to this point, which is just a bunch of filters. And then we said, let's generate multiple outputs from this, which in this case, we're just creating 2 histograms. So the nice thing about that is, right, up to a certain point, the calculation is the same. Both of these plots are fed by the same pipeline, so it's not filtering the data twice to feed these 2 plots. It's doing it once. And then generating these 2 outputs from it. And obviously, we can have any number of outputs generated from the same thing. Okay. Now we're building up to something slightly more interesting. We're again starting with just a subset of our data and then making that interactive. One thing you're seeing here is that interactive previously, we just used .interactive and then called it without any arguments. We can actually pass arguments to this, which are arguments to the layout that we're generating from the output of this. So in this case, we're telling it we want the sizing mode. Don't worry too much about what the sizing mode means, but in this case, it just means make the plot responsive in width so that it fills the screen. I'm then, again, defining a date range slider, a magnitude range slider, again, doing our filtering on that data set, and then generating this geoplot, which is fed by this. And again, ooh, not pretty, right? It's flickering. That's not too nice. We're going to see that's a problem. So in certain cases, right, what's happening, this interactive pipeline is basically reapplying all our transforms and so on, getting our output, and then at the end, it's re-rendering the output entirely. That's not always what we want. HoloViz actually, if you saw earlier, some of the widgets in the hvPlot sections, we didn't get a flicker when we kind of dragged, switched between different plots. And so that leads us into so-called terminating methods for interactive. So by default, when we render a interactive pipeline, it's giving us the widgets, it's giving us the output, whatever the output might be, whether it's a plot, it's a table, whatever. And it's putting that into a layout, and underneath it all, there's just a panel layout, a column of these widgets, and the output, and they're put together, and that's just what it renders as. And so what we actually have is this geo object, right? And when I plot this, what I get, again, is another interactive object. Right? Underneath it all, it's kind of chaining these things and doing all the magic. But what if we actually want a hvPlot object as the output? What if we actually want a panel object that we can further manipulate? Or what if we want to apply linked selections to this thing? Linked selections, HoloViz linked selections know nothing about the interactive objects. They don't know how to deal with them. And so we need to terminate our pipeline to give linked selections function an object that it knows how to deal with. And there's one use case. There's many reasons you might want to terminate, which I might go through in a minute. So here we're terminating this mag print, and we should probably work on giving these things better reppers so that we can actually get some information of what this pipeline is. Right now it's just this generic interactive object. I now terminate that into a HoloViz object, and now we get a more familiar repper of this. So this is a dynamic map now, which again renders as a plot. So we're terminating these two things, then laying them out, and now I can apply linked selections to this because this is now a HoloViz object. And so we now have our pipeline, which is fed by these widgets. And so I can also terminate and say, just give me the widgets that are feeding this pipeline, right? And so I now have this interactive output that we have applied linked selections to. I have these widgets. And so now we have this crazy interactive pipeline, right? It takes a little while to get your head around. We've got a data set that is filtered by these widgets. It is then fed into this HoloViz plot. This HoloViz plot has this linked selections applied so that we can further subfilter the data. Hopefully that makes some sense. It's a long chain of events. But the brilliance of this, right, is that we've done all of this in using APIs that hopefully you've already learned, you already know about, whether those were Pandas APIs or these hvPlot APIs or the linked selection API. So there's four termination methods in total. Let me quickly show you all of these. So HoloViz, did not like that. Oh, okay. No, you can't. If HoloViz doesn't, like the output of your pipeline isn't a HoloViz object, you can't terminate as a HoloViz thing. So in this case, filtered subrange, I have two options. I can just give me the panel, kind of the output of this thing, which in this case is a table. Just give me the widgets, or give me the layout of these, and that is a panel object. And so we're going to dig a little bit more into panel objects pretty soon. So here you can see filtered subrange dot layout terminates into a row of a column containing another row of the widgets and this interactive dynamic function, which basically updates the output whenever things change. That's probably a lot to get your head around. You probably have to play around a little bit. But what you should remember is that if we, for example, terminated this geo object into a HoloViz thing, and now I did geo.widgets, we're now having HoloViz take care of updating the plot, and we no longer get this weird flicker. So that's kind of a subtle distinction. Previously, basically, panel was in charge. By default, panel is in charge of updating things, and when panel is in charge, it basically just says, I'm going to re-render this thing in its entirety. HoloViz can be more smart about this thing and say, well, this is a plot. The previous thing was also a plot. I'm just going to update the data in this plot. Right? Hopefully that there's all kinds of subtle distinctions here that you may not get on the first go, but yeah, there's a number of reasons to kind of terminate your application this way.
Just as a background, a panel member can display anything, HTML, display an image, anything, whatever it is. The way it does that is pre-rendered. But in certain cases, like for HoloViz objects, it's pretty more subtle and do nice little things that only re-render certain bits of things and make a much nicer experience. The panel will do anything. So you can get a first app using any tool you feel like. If you want to get a really polished one, you use some of these things. Or don't worry about it.
Yep, that's precisely right. All right, I think we're going to do this exercise now. I skipped the linking plots exercise, but if time at the end, we might. Jim, if you could give me some indication of timing, that would be good. But let's jump into this exercise number 3. Again, it's in the tutorials exercises folder. Feel free to ask questions at any point. And yeah, jump into the exercise. And again, we're going to give it about 10 to 15 minutes. But yeah, you're building your dashboard in a notebook. You kind of, I don't know, we're going to load quickly our data. Let's say we're loading this data in. We're now, we want to display that as a table, for example, widgets, tabulator. So if you're rejoining online, we are now, I'm just giving a quick demo of a nice workflow of working, building dashboards in a notebook. That is in the wrong place. Okay, I'm just going to use some just going to make up some data real quick just to demonstrate this. So yeah, imagine I've done some exciting tables, I've generated some exciting plots. Panel now has this concept of making things servable, which basically means add it to my dashboard. And so in Jupyter Lab, if you're using Jupyter Lab, we have this preview button. And this preview button basically lets you see what does Notebook look like if I deployed it as an application. And so here, for example, we've now kind of, just done this. I can click this render on save button. I can say template equals fast, for example. I can use a nice custom template. I can change the title now. And so in this way, I can, I think it's state template.title, my beautiful dashboard. So in this way, we can quickly iterate, create our little application, and then deploy it. And we'll briefly talk about some deployment options, but there's some documentation about deployment. So that was a total aside, but just if you're using Jupyter Lab, this is a really neat way to kind of iterate and build a dashboard. Okay, so let's jump into this dashboard section here. Again, tons of imports here. In fact, we are now in panel. Basically, certain components are optional, and so you don't want to load all the different components always. So if you're working in a notebook, you need to tell it to load this component ahead of time. And here we're telling it to load the tabulator component. So in this reference gallery, if there's a custom component, it'll tell you what you need to do to load it here at the top. Okay, so we've now done that. We are now going to see what panes are. So panes, as I briefly told you before, panes render some object. It might just be as simple as a string. Here we're rendering the string as markdown. Pretty simple. We kind of have this logo path, rendering an image, right? We just give it to this pane object and it renders it. And then all of these have a variety of parameters to customize it, right? I can say height 150, whatever. So again, if you go to the reference gallery and go to this component, it'll tell you kind of the general kind of sizing related, layout related things are listed in this customization guide. The various parameters to control that particular pane are listed in this section. And then, yeah, it explains a little bit about the component and how to use these different parameters. Okay, so now we've seen, yes, a pane can render some string, it can render an image, but often you don't need to even tell it, right? It has this helper function called pn.panel, which basically takes your object and finds the best, what it thinks is the best representation of that thing. So you give it a string, it'll infer, well, Markdown is a good way to render a string. If you give it a logo, the path to the logo, it'll automatically figure out, well, that's actually a good way. Well, we don't want to see a bytes representation of the image, we want to see the image. Right? And so if we print these objects, it'll be a PNG object, but you didn't need to really declare that because it's pretty obvious that the file ending in PNG is a PNG file. So yeah, what I recommend is you can either print or use type to kind of confirm pn.panel. What did it actually give me? That's how you confirm, right? Simple enough. Similarly, internally, if you give a panel layout one of these things, so if you give a panel layout a string, it automatically, panel doesn't, by default, doesn't know how to render the string. It'll ask pn.panel to infer what this thing is and how it should render it. And then we get back basically this new composite object, which is a row, where the first element is this markdown object, and the second object is this PNG object. And then it will render itself. Okay, so now we're again going to load our data. We're going to create some plots again. So again, our rasterized population overlaid with the sample points. And now we're going to create a little mini dashboard. Pretty, simple enough. We've just created a column of our little header and of our little plot here. All simple enough. And yeah, it's pretty straightforward so far. Of course, a lot of the layout options, there's a lot of options, and you might always have to look those up. But the basic concepts, I think, are hopefully pretty straightforward. These panel objects also have very standard affordances. So we already saw before that servable means added to our dashboard. One other thing is you can always, any individual object, you can say, particularly if you're running this basically on a command line, like just running IPython in your terminal, you won't get these rich outputs. There you can use .show, and .show basically means spin up a little server and then open a browser window with this thing displayed in it. So that's another quick way to kind of quickly preview what this thing looks like. Alternatively, we saw this preview button before. Preview button internally, really all it does is run panel serve and then serves this notebook. So if we, here in this interface, I could quickly, I think, I'm not sure this actually activates my environment, so I might have to do conda activate dev 3.9. This is, you usually activate the environment you're working in, and now I can do panel serve. I think we're on dashboard 6. I don't even know if he marked it as servable. I guess somewhere in this notebook I probably did. I can now give it the notebook, and I can say show. It's now, okay, it's telling me this port is already in use, so I'll pick a new one, 007. It does the same thing. It spins up a server, runs our notebook, and picks up any servable components to display. Okay, so this is what we're leading up to in this notebook. And so this is basically panel serve. Whatever notebook or script you've generated is the main way to deploy one of these dashboards. So you can go to Heroku and deploy it, or you can, there's any number of services. We're still working on kind of collating that list of services, and it's always expanding. Okay. Okay, so yeah, let's put things together, right? We're again going to just rehash what we did in the previous notebook. We're going to create our interactive pipeline. We're going to lay that out together with our little header. And now we've built a little dashboard, which gives us this interactivity. Again, here I should have probably terminated this and done geo.holoViz and geo.widgets separately so that I don't get the flicker, right? It's not entirely, we can have control over whether it should update the ranges. In this case, I didn't set that, so it's kind of distorting our plot a little bit. But if I cared enough, I'd fix that now, but we don't really care. Okay, so just to rehash, right? We've kind of covered what are panes in a panel. Panes are window panes onto whatever object you're displaying. Panel will automatically infer for you what the ideal representation might be. You may have to correct it, right? In certain cases, a data frame could be displayed as using the standard repr, or it could be displayed as a tabulator widget. And in that case, you have to declare it explicitly. We've discovered a little bit about how to lay things out. And again, to get an overview of all the different layout components, look at the reference gallery. So for example, I could use tabs. I could say, I want a flex box, right? And so now it's reflowing things depending on the size of the screen. I don't actually know why it's reflowing in this case, but yeah. So there's a number of layout components. We've seen how do I serve my dashboard, how do I preview my dashboard or my little application. So show is a quick way to do so. Servable is the way to declare something if you want a panel serve it. And then we've kind of started building up to an application that's actually somewhat interesting, does something that someone else might actually want to look at. Right? And so in the final version here, we've built a little dashboard using everything we've learned so far. Right? One particular thing to note here is Panel has the concept of templates by default. Right? There's no template. Well, there is a template, but it's just a bare page, white page, kind of boring in the background. If you declare in the panel extension, I want to use a particular template, and there's a few of them, whether that's Material UI based or Fast UI based or Bootstrap based, you can do so. And then that adds basically different regions to your little application. I can then customize certain things about that template, give it a title, set the width of the sidebar, for instance. And then I can use the layouts to lay out the different components, mark different components as servable. So here, the servable thing, basically, by default, servable just adds it to the main area. If you use this area argument, you can say, well, actually, I want this component in the sidebar. I want this component in the header, and so forth. And then I have my full dashboard. Pretty nice. So let's run that again. I'm going to serve this again and look at that dashboard. Oh, I marked the wrong thing as servable, and that's what you get. Sorry about that. Yes. I've done I've added a show here, which shouldn't be there. I don't know if I can rewrite the entire thing, but yeah. So hopefully you can do so. To activate the right environment, you might have to. Okay, so I can quickly show you how to. You would do conda activate ends default, and that should activate it. So you cd back into the main directory. Then CD back to the tutorial, and then you can do panel serve 06 dashboards.fp1b show, and that should launch the little dashboard for you.
The reason you had to actually accomplish using any kind of project to launch your whole thing, that thing was done in the environment, but it didn't change where your shell was. Your shell is still whatever environment you started in. Nothing, no relation to this, because this is an isolated, independent project meant for reproducibility. If you notice that it seems to have reproduced for everybody, but it's reproducing outside of your world. If you want into that world, the world of that project, you have to activate it.
So yeah, now we've built a little application. It has nice little, the template has nice little affordances, such as a sidebar that you can expand and collapse. We've got a table, we've got a plot. They're all linked together. In fact, I'll quickly show you something about linking these plots together in a minute. Yeah, so far, previously, one thing I hadn't shown you previously is we did linked selections with plots entirely. In actual fact, we have control over, with this linked selections object, we can actually generate a pipeline that eventually feeds into our tabulator widget. So here we have the tabulator widget. We start with our filtered data. We pipe that into the linked selections filter function. And then we tell it we're depending on the selection expression. Don't worry about all this. I know it's a lot. Your brain's probably fried at this point. It's just to show you you're not limited to plots. You can chain pipelines in arbitrary ways. You can have nice little tables, and you can compose the entire dashboard in this way. Okay, so at this point, we're going to let you build your own dashboards. I would perhaps, I think everyone's brain is probably a little bit fried, maybe partner up, but it's entirely up to you. So we are, I think, now in the building a dashboard section. Yes, I would very much recommend, you've got us here. If you want any concept you don't quite get, we're happy to help you with. Also, there's one more section with more advanced dashboards. I'm not entirely sure, your brain has been filling up and filling up and filling up, and it's a lot. I don't know how much more I can fill in there at this point. So yeah, I recommend asking questions, and I might dive a little bit into some other features in the last half an hour.
That's a good point. You cover all of the tutorial, you covered some fraction of what the HoloViz tool is.
All right, I imagine everyone's brain is fried, but I'm going to try and run through one more section. And then I'll do some demos of something we've been working on, which is PyScript, and how that interacts with Panel. So hopefully you can finish your dashboards. Always love to see what you build. So you can also share those at discourse.holoviz.org. For now, we're going to move on to section 8. We're going to skip section 7, just because it's quite deep in the weeds of HoloViews, and we're instead going to get a little bit more in the weeds on Panel and see how some of that works. Okay, so let's get started. Tutorial number 8 is on custom dashboards. So far, all the dashboards, a lot of the interactivity we've built into our dashboards or our little data apps has been using the interactive API. And so that's powerful, particularly as you're working with kind of data. But you're not always starting out with a data set. You're not always manipulating Pandas data frames or Xarray data sets. The world of data apps or just generic web applications is much wider. And so we're going to introduce you to some ways to add interactivity to your applications using some other approaches. Okay. So that's what this notebook is about. So we're going to start, again, we're going to load panel PN extension. Maybe I'll even load a component like tabulator for later use. And we're going to load our data. And we're going to start in the same place. We're going to create a widget. You know how widgets work now. They have a value, they have parameters. And here that actually will matter a lot more and be quite important. So again, we have our value. We're going to create a second widget. So to allow us to filter by a place name, for example. And now we're going to define, instead of defining a pipeline, a kind of a Pandas pipeline, we're going to define a filter df function. So here we're just defining a function which does the filtering, combines our filters like the lower filter, the upper filter, adds basically filters on the place name based on the string, and then returns the head of the data frame. So how do we make this interactive? Well, we kind of saw something similar earlier. We're going to use a functionality called pn.bind, so panel.bind. Basically means bind these parameters or these widgets to this function such that when those widgets or parameters change, the function gets reevaluated, the output updates. Right? And so here we're going to do place our widgets in a column. We're going to bind the magnitude mag filter to the magnitude range arguments of this function, bind the place filter widget to the place argument of this function, and then wrap that in pn.panel so that we can give it a width. So a lot of us, you asked me just now about kind of how do you size tables correctly. That's actually a pretty major issue right now. We're working on a complete overhaul of the layout, and so that will eventually just resolve itself. Right now, we've kind of just manually set the size. And so now, if we evaluate, I should probably evaluate the other cells. If we evaluate this, we can now, for example, search for a place, I don't know, Japan, and now it recognizes the place filter has changed. It calls the filter df function with this new place name. This now it uses the string contains method on this column to filter the table with that value, and then updates. So pretty similar. We could have probably achieved this with the interactive function, but underneath the hood, this is basically what interactive is doing. But you could do anything else you want in here. It doesn't need to be a data frame we're working with. It could be, I don't know, you could run a database connection. You could do any other manipulation you want. Right? We can see here, what this looks like is we've got the row containing this column, containing two widgets, and then we've got this param function object. If you kind of remember from earlier, that is exactly what the interactive pipeline actually returned. So here we've just done this step manually, but basically it works the same way. So now a quick exercise. Try to declare a spinner widget. So pn widgets.spinner. And then declare a function that depends on it. Or, well, maybe actually create two spinner widgets and then add those together and then return their value and lay that out. Widget 1, widget 2. One hint, you might want to provide ranges on these. So yeah, we should end up with something like this. Change it up a little bit. So yeah, pretty simple. You declare your two widgets. You declare a function which takes the values of those widgets as inputs. And then you create a little layout. Here I basically added some text in the middle to do the functional expression, the expression that we want it. Again, you may have to declare the width manually here, which is a little bit annoying, but again, it'll be resolved soon. So now I can do 10 plus 10. That didn't actually work. So if you want it, you can also directly return a panel in here. That should work. Oh, it's max. Okay, so let's see. Is that the solution we got? Oh, we haven't updated the solution, so you're getting. Okay, so this is an older API. We now recommend you use p-bind instead of this decorator. Not everyone knows about decorators. So this is what we recommend. One thing to note about bind is you can both bind positional arguments, or you can bind keyword arguments. So I could say value 1 and value 2, and then even though I put them in a different order, right? Value 2, value 1, that'll still work. So yeah, if you're familiar with functools partial in the standard library, it's basically the equivalent, except it has that additional ability to kind of watch the changes in the parameters and tell panel when to reevaluate it. Okay. Next, we're going to look at callbacks. It's another API to do interactivity. Certainly, bind is very, very useful, but usually it's a reactive way of expressing dependencies. Sometimes you want to just change one thing. You want to have a side effect that gets triggered when you click a button, or you want to have a side effect that gets triggered when a value is above a certain other value, right? And so that's where callbacks are useful. Callbacks, and now we're getting into param again. Here we're going to declare a slider. We are now going to select a particular row and create this row pane from this selected value. So we can briefly do that manually. We're going to look at the row pane. Right, it's just selecting one particular row. So that's nice enough. And then we declare a callback that updates this object whenever this parameter on this row slider changes. And so the API for that is rowSlider.param.watch. So we're watching this particular widget, and when the widget changes, we call this callback. So this callback could obviously do anything. Here you can provide a list of parameters that you're watching, right? And here we're watching the value. You can also watch, well, I don't know, you might have custom parameterized objects with any number of parameters that you might want to watch, and that's when this comes in useful as well. And so here we've now, basically what happens, right, we change the widget, the watcher gets called, the watcher updates the object that this pane is displaying, and so when I drag it, the pane updates and the display updates. Fairly straightforward. So these two APIs are, in your journey towards building more complex data applications, these will come in very useful. If you're just focused on kind of quickly exploring some data frame, stick with interactive. Totally fine. But callbacks are very useful when you have very complex dependencies. This p-bind function is very useful. Again, it's kind of an intermediate level API where it's pretty simple, right? You just declare a function, it returns something, that thing updates when the widgets change. While here you have, with a callback, you have much more control over kind of what changes you even, so here, I think one thing I glossed over is that instead of getting the value in this case, what we're actually getting back is this event object. So let's print that. We get back this event object, which gives us some more context about this thing, right? What was the object that changed? It was the int slider. What was the old value before this happened? It was this. What was the new value? It was that, right? And so you have some more context. You can have only when the old value was this, the new value is that, do you make a change? You have more information. You can do more precise updates and so on. Any questions about that part? How are we doing on time? Okay.
Just to really put that in context, interactive, the design of that is, I'm living in my data frame, I'm thinking about my data frame, I'm exploring my data frame, now I'm adding interactivity to it, but really it's still all about the data frame. Now part of that, what you just go do was, I'm trying to build an app. I want to put some stuff together, I want to do stuff. It's not about a data frame, it could be about anything. The app could be reading temperatures from some device, we don't know. It's anything. So we have the appropriate APIs that are designed for different use cases, and they all end up in the same object generally. So underneath all of this is some objects that are rich and composable and usable. How you get to those objects, and the best way to get to those objects depends A, on what you know, use the way you know. But B, which ones should you learn? Well, you're a scientist caring about some data sets. Stick with hvPlot as interactive, learn from there. That's going to really give you lots of support, lots of ability to do things. If you really think, I want to know what's the craziest app I can do, don't start with that. Don't start with that interactive. Start with panel API, start with panel.bind, drop down the lower level things and panels to need them. But always, so we offer some different starting points, and you drop down and you hit the limit. That's the shortcut, and then you keep dropping down if you need it, and if you never need it, don't do it, unless you're forced. We're assuming you're just trying to get something done, trying to get your job done and go back to your life. And if your job is about understanding some data, use hvPlot, use hvPlot.interactive, explore your data all you want. Eventually you can ship that as an app. Great, other people can explore your data. But if that wasn't your goal from the start, if that was your goal from the start, you can do it that way, you can also use it the way you do it.
Precisely. And in fact, each of these builds on top of each other, right? The interactive API is built on top of bind. Bind is built on top of these callbacks. So it kind of neatly stacks. And you're, as a user, use what makes sense in your particular use case. So I don't know if we want to go all the way through this final notebook. We're definitely
I think we've ever reached it.
no.
In a 4-hour tutorial.
Yeah, I mean, usually Jim spends the first hour just talking. So, yeah, I don't think I'm going to do that. So I might show you some things. So obviously, we've kind of covered exploratory. You explore in the notebook, you iterate, you so on. You build an application. We kind of showed you how to prototype an application, how to run an application. What we didn't show you is how to deploy it. There is multiple approaches here. I won't go through the process of kind of log into AWS, set up your EC2 instance or whatever. You can do that. There is, if your organization manages a Jupyter hub, there's some plugins to help you kind of share it within an organization. And I will be, I think, writing a blog post about some of the deployment options very soon. So yeah, I won't go through that either. What I'm going to go through is a new approach. So if you kind of listened to PyCon, our CEO, Peter Wang, announced a new project called PyScript. And PyScript is basically the idea of writing Python entirely in HTML. So you don't need a server. It's running in your browser, and it's built on a project called Pyodide. Pyodide basically relies on a technology called WASM. And that allows you to kind of write entire applications entirely in HTML. So if you were around in the 90s and wrote your first GeoCities website, you can now do that, but now you have the power of Python, and it's awesome. And I'll dig into kind of some demos that you can build with Panel. The next release of Panel actually is going to be focused around the idea of quickly building Panel applications that run entirely in your browser. We'll even provide a utility to kind of take your application, spit out an HTML file, which uses PyScript and Pyodide to run. So let's kind of see what that affords us, right? So here, we're going to start this little application. One big caveat or drawback of PyScript right now is it's pretty slow, but PyScript and Pyodide themselves are not slow. What is slow is that you're downloading Python into your browser. And unless you've already done it, kind of loaded this page before, and your browser's cached things, you're downloading all of NumPy every time you're accessing a website. You're downloading all of Pandas. You're downloading all of Bokeh, Panel, and so on. Your entire stack gets downloaded every time. It's kind of crazy. We're working on improving these things. But what you get out is pretty cool. So before we try out this application, let's just look at the HTML. And surprisingly, it's actually readable. We're not in JavaScript land where you have 50 different frameworks and you need to kind of, learn all of them. So here, what we have is a PyScript tag. We have our usual imports. We have Panel, we have Pandas, we have param, and now we define an application. And I didn't actually show you this way of writing applications. It's built on param, but the basic idea here, right, is this is Python in your HTML file. Pretty neat. We've defined various components here. We have some callbacks, so we're depending when the hour parameter changes, do this. And so we have various methods here that basically do the same things our callbacks, the callbacks you just learned about did. And then we basically point it to a data file, load that data file, instantiate our web application, and just say servable. But in this case, servable doesn't insert it into a template. It actually targets a particular DOM element. So here, up here kind of is the layout of this page, right? So we've got a header bar. We've got a we've got this div element, and we've given an ID called Widgets. And then we've got this other div element called plot, which is where we're going to insert the plot. And so from Python, we can now say directly inject this Python object, or the representation of this Python object, into this region of the page. So that's pretty cool, right? We can even manipulate the DOM directly from Python. Yeah, all we've done here is said, take this deck.gl plot, insert it into this particular DOM element, take these controls or these widgets, panel widgets, and insert it here. And then finally, we've created this PyRepl component, which basically gives us access to the running Python session in our app. And so just the same way as you have a notebook, we now have a notebook cell effectively in our dashboard. So that's quite neat. So here, this particular example is just this 3D plot, right? Displaying New York taxi data. I can change the radius. You can see how responsive this is, right? Because we no longer have a server that's communicating with our browser, which is potentially sitting halfway around the world, right? This is all running on my machine. It's not even sending any data anymore, right? So this is really neat for applications where the data is sensitive and you don't want to have a server and deal with security issues. You can build entire applications you can send as an HTML file in your organization as an email. They open it, it fetches the data, and then, or even you embed the data, and then they can use it. So here we've exposed some controls, we've exposed the radius, we can see how the taxi trips change by the time of day. We've got a little play button, which basically we can do at a periodic callback, which just changes the hour of the day, so we can quickly go through this. see how responsive this is, right? It's pretty neat. And so here's the real superpower now. You're now an advanced user. You've built this dashboard. We've only exposed these few controls, but it's a Python session. So we've got our app object. We've got basically a parameter that's the current view that we're displaying. So when I update this, I can say df, and df, I think tip amount is greater than df tip amount quantile 0.95. So let's display only the taxi trips that have where the tips were and then above the 95th quantile. Right? We can do all kinds of custom queries in this, and we're no longer locked into kind of this either we're now in this hybrid space where we are building an application, a nice looking application. No longer are we locked into the notebook format or whatever. But we still have the full power of Python to do custom analyses. And this is really only the start. So I basically got the task of build some cool demos for PyScript. And that's what I did. I didn't spend very much time on it. And there's cool things I came up with. So I'm very excited about this. This opens up the ability to kind of work with data in really new ways, build applications in really new ways. And yeah, it's only early days. There's still tons to improve. Maybe we'll look at one more demo.
That one, can you explain why it was showing up at local instead of just a HTML file?
Oh, right. I think this could actually work as a, 1 second.
Ideally, this should just be an HTML text file. You can send something, and they view it
Yes.
in their browser. Everything is running in the browser. There's no environment. There's no setup. It's just that file, and they run it and all executes in the browser.
I don't think there's any reason.
For development, sometimes we need to do it here, but I don't think after development we need to do this.
Right, so let's try it. So let's try a different one. Panel k-means is another nice one. Yeah, should work just fine.
Now, that could have been in an email.
Yes. So I know it's not even an HTTP server involved, right? I emailed this, downloaded it into my own downloads folder, and just double-clicked it, and I've got a nice little application. Again, built entirely. I think this one's actually built using APIs that you would have learned about by now. So here, this is actually running scikit learn clustering on this penguins dataset. So here is a Vega plot of these 3 species of penguins. We have a table down here of the different species, right? Of all the different penguins. There are various measurements about them, just their bill length, so the beak length, the length of their flippers, their body mass, and so on. And now we're running scikit current learning clustering, again, entirely in our browser. And finding we're trying to find cluster these species into, or just raw data into 3 different labels, which pretty much coincides with the actual species. So you can see here there's some misclassification. So I've encoded the label the clustering has done with the shape, and then the color represents the actual species. And you can see here mostly squares are meant to be red. There's some circles which are wrong, and so on. But again, entirely running in our browser. We have a lot of the functionality. We have all the nice functionality that you just learned about. So we have linked selections, for example, here. So I'm kind of filtering, moving around. Our table updates and response. I can change what we're plotting. I can even rerun the clustering algorithm to generate different numbers of clusters. Obviously, we know it's 3 species, but we can change that. And again, we can just inspect the source code. And yes, there's a bunch of JavaScript imports up here. But really, this is, let's count, 159 to 84. It's 70 lines of Python for a really nice application you can just send as an email. So yeah, the main reason, deployment is hard. We need to do more work on documenting deployment, but this skips that step entirely. Right? It's really pretty exciting, and it's only early days. I think I'll call it a day at this point. You guys can ask questions, but really, many thanks for attending. It's been great being back at SciPy. Have a great time. Thank you.